let's look at how to find intercepts using a graphing calculator. As always, I'm using a TI-84 plus CE calculator, but a lot of what I do will be similar on other Texas Instruments calculators. So let's go ahead and graph a line. I'm going to start with just a basic linear function. So to graph, I'm going to go ahead and press y equals. And again, the X button is the one right next to the alpha key. So let's go ahead and type in x plus 3. And let's just start with hitting that graph button so I can get a picture. Now, I always tell students to start out with, you can always use that graph to at least get an approximate idea of where any intercepts are. So here, looks like we've got our y-intercept at about positive 3, and looks like we've got my x-intercept at about negative 3. Now, because this is a nice one, those are indeed my intercepts, but particularly for nastier graphs, sometimes it's kind of hard to tell. So one thing I tell students is let's start by using the table. So that's in blue. Again, to get the blue stuff, I'm going to hit the second blue key. So let's hit second and then graph to access my table. So if we remember graphically what an intercept is it's where we have zeros. So I'm going to scroll down so we can see this better. At negative 3 for x, we've got a y value of 0. So that is indeed our x-intercept as we thought it would be. And then scrolling down just a little bit further, when x equals 0, looks like my y value is 3, which does make it my y-intercept. So I always start with the graph to get an idea of the approximate value, and then I'm going to go ahead and open that table to check to see if we do indeed have zeros. So again, when the x is 0, that's my y-intercept. When the y is 0, that is my x-intercept. Now I'm going to look at finding intercepts for nastier values in a different video. For this one, let's look at finding the intercept between two graphs. So I've got my one graph already. I'm going to go ahead and call that y1. And let's do negative x plus 5 as my other one. So I can go ahead and graph a second line. I'll just go down to y2. As a reminder, that is negative x, not subtraction. So I'm going to come down here and hit the negative sign. Again, if I put subtraction first, let's try typing that in, my calculator is going to give me an error because it thinks I'm subtracting something. So let's come back up in here and change that to negative. Again, I always encourage students, don't use that term minus. Try to think of it as either negative or subtraction to try and help me make sure I'm picking the right button there. So let's hit graph. We've already seen that first line in blue, and now y2 is showing up in red. The nice thing about the colored ones is I do have those different colors, so I can see them a little bit more easily. Now again, I always start with the graph to at least get an idea of approximately what I'm expecting, and it looks like it's going to be x equals 1. Now again, that might be the exact value, it might not be. Let's go ahead and find out. So I'm going to go to the calc menu. So I'm going to hit second and then trace to access that calc menu. You can see the word calc above trace. So let's hit second trace to pull up that calc value. And I'm looking for an intersection. So let's go down to number 5 where it says intersect. And as always, we can go down and find that, or you can just hit 5 on the number key to access that. Now it's going to ask me a couple of pieces of information. It's going to ask me what the first curve is. You'll see a cursor on one of the curves. Up at the top, it's also telling me y1 equals x plus 3 to tell me that I'm on that particular line. So I'm just going to go ahead and hit enter there because I am on the first one. It's then going to ask me the second curve. And you'll notice I'm now on that red line. And up at the top, it says y2 equals negative x plus 5. So again, my graphing calculator is telling me which line I'm on, and I'm going to go ahead and hit enter again. Unless you've got 3 or more lines, we'll go ahead and just be able to hit enter and enter for both of those without really changing anything. Finally, it's going to ask me to guess the intersection. This is primarily used if I have 2 or more places where these two graphs are intersecting. This one's only got the one, so it's going to be a little bit less difficult. but if there are more than one, you will have to do one at a time. Now, I always tell students, you don't have to be exactly at this value. It doesn't look like I'm exactly at the value, but I'm close enough. So again, I'm just going to move that little cursor until I'm approximately where those two graphs cross, and then let's hit enter again. And now it does give me my exact value. And you'll notice most of the time we only want the x value, but it is going to go ahead and give me that y value as well in case I need it. Now, as we saw, this one did only have the one intersection, so let's go ahead and go back to y equals, which I've already hit, so that we can look at another one. So now let's use a different graph. I'm just going to go ahead and erase that first one. Let's do x squared minus 1. Now again, I use that generic term minus, but it is subtraction. Let's make sure I hit subtraction instead of the negative sign. And let's hit our graph again. So again, there's my first graph, y1. Here comes the second one. That is now quadratic, so I have two intersections this time. So we'll do the same thing. Let's hit second trace for my calc menu. And again, I'm going to go to option 5 there for intersect. My first curve is still that y1, so I'll hit enter. My second curve is y2. Let's hit enter again. Now again, I have two intersections. I have to do them one at a time. I'm going to go ahead and do the left one first. Let's come until we're, again, approximately there. If I don't get it exact, that's all right. And hit enter. And this time my values are not so nice. I've got about negative 1.56155, comma 1.43845. I always remind students this is a decimal approximation. If there's a radical in the answer, the calculator is not going to give that to me exactly. I could then check on my main calculator, and I'll do that in a minute, but again, the graph at least is just giving me a decimal. So again, to get the second one, I'm going to have to do this a second time. So second trace, let's go to intersect. Again, my first one is y1, my second curve is y2, but now I've got to move my cursor along until I get to the approximately that right one, and let's hit enter again. And now I do get that other value of approximately 2.56155, comma 5.56155. So again, if you do have more than one intersection, we are going to have to go ahead and do them one at a time. You cannot just go from one to another with the Texas Instrument calculator. Now again, the calculator gave me decimals, but what if I want an exact answer? As a reminder, the intersection is where the two graphs are equal to each other. So I would set them equal if I was solving this by hand, and I would get the quadratic x squared minus x minus 4. So I subtract the 3. Now that does not factor, oops, pull that back. So I would use the quadratic formula, and I went ahead and already did that. I got 1 plus or minus the square root of 17 over 2. How do I know if those are the same? Well, let's go back to my main menu, and let's type that in. So let's type in 1 plus the square root of 17. You'll notice I've got more than one term there. That's why I've got parentheses. Divide it by 2. And that does look to be that decimal. Let's check the second one. 1 minus the square root of 17 all over 2. And that does, oops, I forgot a parenthesis. That's why that one didn't work. Let's try that again. 1 minus the square root of 17. Make sure I have my end parenthesis in there. Divide it by 2. There we go. That does seem to be right number. I always remind students, if I try to use my math arrow frac here, that is not going to turn it into a fraction because it has the radical. So again, this is how I check, is I get the decimal, and then I type the exact number in my calculator and ask, do those two decimals look like they're the same number? So again, the calculator won't turn that into that, but I can go the other way around to check.